assignment 1, problem 1. Algorithm 1 and algorithm 2 are implemented in this assignment1.py file. These are almost the same as the pseudocode given in the question, except that I implemented a check before the implementation to see whether the input of the parameters are valid positive integers. So let's see the execution time. I'm importing this Python file into Jupyter Notebook and check the execution time here. So here I set the number of boards to paint to be 1000, and I looped them 100 times to get the average of the CPU calculation time for 1000 boards. This is making it to be more accurate. We can see that for algorithm 1, the average CPU time is 100,000 nanoseconds. For algorithm 2, the average time is 1.4 million nanoseconds. One reason is that, as I said earlier, I checked whether it is a valid positive integer before I implemented the paint single board method. But we can see that for the recursion method, it is actually checking it way more times than we wanted every time it calls the recursion function itself. Therefore, let's try to remove this part and see whether it influenced the result too much. Save. Yeah, let's see. All right. We can see here both of the average CPU time improved, and for the algorithm 2, it improves 2 times more, and algorithm 1 only improves a little bit. So that part of checking did influence it pretty much. However, we can still see here algorithm 2, the calculation process CPU time is several times higher than algorithm 1. One reason is because that for Python programming language, the recursion, it needs the allocation of a new stack frame. Therefore, it could be a little bit more expensive than the simple iteration method here. But we have to note that the time complexity for both of these algorithm function are all big O of n. For algorithm 1, it's very clear to see here there's only one loop indexed from 0 to the length -1. For algorithm 2, because this is still visiting like each leaf node to paint each single board, so this is like the n operations. For the intermediate process, there are log of n layers in between, and if for each intermediate steps there are a constant c of operations, then it is a geometric sequence, and if we accumulate them, it gets the result of c multiply n minus 1. So in total, these are still the big O of n for algorithm 2. And this leads to the third question of which algorithm is better. In this specific problem, I think algorithm 1 is better because this is a very simple and easy implementation of iteration, which takes less time. However, for recursion, there are some cases that the recursion is easier to implement. For example, the problems that's like that needs the tree type. It is easier to implement, and it is also more consistent than as the math formula that human can digest. So, and it might not be that easy to implement it with a simple iteration process. So in those kind of cases, the recursion method might be better.